Every app has users. Every app has data. And at some point, every app needs to answer one question. Is this user allowed to do this? Most developers get this wrong. An if statement here, a rule check there, maybe a middleware that checks if user is an admin. Then the requirements changed. Only the post author can edit their own post. Only weekdays. Only inside the user's organization. Unless there are an emergency responder. Suddenly, your if statements are everywhere. They are in your routes, your services, your database queries. Nobody knows what the rules actually are anymore. And when something goes wrong, when users accesses data they shouldn't, you have no idea why. This is the authorization problem, and it's solved. Actually, duck-iam is a TypeScript first authorization library, zero dependencies. It gives you rules, the simplest stuff editors can write. Users can read policies. The complex stuff only on weekdays, only from trusted IPs. One engine that combines both and gives you a clear yes or no. An explain tool, so when the answer is no, you know exactly why. By the end of this video, you will have a complete authorization system. For real application, we will go from this, couple of if statements everywhere, to a very structured, simple way to know what you do. Clean, auditable, testable, type safe. Here is what we are covering. No fluff, no slides. Just code, running, live, building, up from zero to production. Let's start. Here you guys, this is actually the brief before we actually get to the chapters. I'm actually going to give you a little bit of what's really going on here. So this video is all about duck-iam in a more structural way. So I encourage you guys to check out the documentation because it contains a lot of information that I'm not actually going to mention in this video because it's a very big library and there's a lot of things in it. So explaining this library could take hours and you don't have that much time, so you can search for what you need right there. And it's more complicated. There's a lot of scenarios we're not actually going to be able to cover it in this video. What is duck-iam? So duck-iam is an authorization engine that unifies rule-based access control and attribute-based access control into a single evaluation pipeline. We define rules with permissions, write policies with conditions, and the engine evaluates them together to produce an allow or deny decision. Everything is type safe. Action, resources, scopes, and rule IDs are checked at compile time through const assertion generic. If you misspell an action or reference a resource that doesn't exist, TypeScript catches it before you code run. So it's completely type safe right here. You're not actually gonna struggle with this. So why duck-iam? Most authorization libraries force you to choose between RBAC or an ABAC. RBAC is simple, but you cannot express expressions like editor can only update their own posts. ABAC is powerful but complex, defining every permission as policy rule is tedious for common rule patterns. Duck-iam combines both defined rules for the common cases and policies for the edge case, and the engine merges them into a unified evaluation. Rules are internally converted to policies, so same condition engine handles everything. So this is actually what we call synthetic transformation here. What do you get? This is actually what you get. You get rules with inheritance, policies with conditions, type safe builders, or combined algorithms, like we're going to discuss this in the chapters, and multi-tenant scoping. We are also going to discuss this, tooling and all that, built-in caching, debugging. So yeah, here we are, chapter 1, rules and your first permission check. Let me define the concept of this chapter. Define a rule, wire up the engine, ask yes or no question. How this library works? This library works like that. You define a rule, you import define rule from the library itself. You give it an ID. This is the ID of the rule. And you give it a name if you want, or a description. These are optional things. And you give it an action right here. These are also optional. These are just like a method chain right here. These like it's not actually like optional, like real optional. You're gonna give it more description because these things actually gonna appear right here in the terminal. Console.log viewer, as you can see right here. I just comment this out. Chapter 1. It's just gonna give you these information right here. These information is gonna help you a lot if you want to debug or stuff like that. So we actually have grant right here. So when you hover on it, I actually have documented this library well, so you're not actually going to struggle reading or actually knowing what a functionality is. So the grant right here grants a single unconditional permission on an action resource pair. So you give it an action and you give it the resource right here. As you can see right here, you give it an action, resource, grant read, post, and you're going to grant read comments. We're going to revert back to the previous result. As you can see right here, we have a memory adapter. We have too many adapters right here. If you check the documentation, check adapters right here, and you can see there is too many adapters. This is one of them. Like we actually have Prisma, we actually have Drizzle, we actually have HTTP adapters, and one of them actually is memory adapter. This memory adapter right here creates an in-memory adapter optionally seated with initial data. Well, and the initial data right here are the assignments right here. As you can see right here, we actually have created the rules. These rules actually are the viewer as an array of rules. When we actually have assignments, that's the user we have right here, and we give it a rule viewer. It accepts other options like attributes and policies. We're going to talk about these later. And we have an engine right here. This is the main engine that do everything. The authorization engine, the central runtime that evaluates access requests against RBAC rules and ABAC policies. This engine loads rules and policies from its adapter, caches them with configurable TTL, converts RBAC rules into ABAC rules via rules to policy, and combine all policies. So a deny from any single policy is final, as you can see right here. So right now we pass the adapter. As you can see right here, it accepts other properties, as you can see right here. Hooks, cache TTL, max cache size, default effect, and stuff like that. And right now, this is actually like the thing that you would love to do all the time, which is, checking. Checking is very easy right here. As you can see, we have the can. This is actually one of the methods on the engine itself. The engine does actually include a lot of methods, as you can see right here. We're going to talk about most of them actually in these chapters. So the can right here, what it does, simple Boolean check, can this user do this action or on this resource? So you give it so this is the user, this is the action, and this is the resource. As you can see right here, we give it a type post just to identify it. This is the ID of the resource itself. So when we run this, it tells us, oh, this user, Alice, can read this resource. Yes, because Alice is a viewer, so it does have access to read access on both, but it doesn't actually have mutation access on the post resource, so it does give us false. It's pretty easy, pretty fun, and yeah, I think this is actually, the end of this chapter 1. I'll see you in chapter 2. Chapter 2, Rule Inheritance. Concept. Let me define the concept of this chapter. Rules inherit permissions from parent rules. Pretty much simple, as you know from object-oriented programming. It's the same thing, so there is no invention here. So pretty much what you do is you define a rule. You give it a name, you give it some grants right here, you grant some permissions, and what do you do when we define another rule? The editor, we give it an ID, give it a name, and we inherit the viewer. It gets everything the viewer has. So what the inherits does, it declares a parent rule this rule inherits from. So the rule receives all the permissions from every listed parent, resolved recursively. Multiple parents are supported inheritance cycle are handled safely. You could ever think of as being checked in more, so don't worry about this. Inheritance is pretty safe, so we also grant a couple of permissions right here on certain resources. We do the same thing for editor. We inherit for the admin, we inherit editor, and we grant all. The grant all right here gives all the permissions on a resource. As you can see right here, grants all permissions, wildcard on a resource. Yeah, so it's the same thing as the grant, and you grant a star, a wildcard on a user, for example. So it's the same thing as grant all user right here, just a shortcut. So we put the rules right here, and we have like 3 users right here. Alice is a viewer, Bob is an editor, and Dave is an admin. And we add the adapter to the engine, and we have our own post right here. And we do checks for the viewer only. So this right here should be Alice can read post, which is a post. Yes, she can read, but she cannot create. Also, Bob can read, Bob can create, Bob can delete. So because it's inherited. Also the same thing for this. Dave as an admin inherits everything. So he can read whatever, he can delete whatever, as you can see right here. So this is pretty much, simple. If you try to run this file, as you can see right here, these are the same values that we expected right here. Chapter 3, Conditional Permissions, ABAC on Rules. So let me define a concept of this chapter, which is permissions can have conditions attached to them. Is owner checks resource.attributes.owner_id strict equal to subject.id. So how does this work? So let me actually just toggle this. So pretty much we define a rule, we grant certain rules. There's something called the grant when. What it does, if you try to get the documentation, so it grants a permission that only applies when a condition holds. The callback receives a when builder, all conditions added aside. The callback must hold simultaneously, and semantics, for example, and use w, which is a when.isOwner as a shorthand for checking resource.attributes is owner ID equal to $subject.id. We're going to talk about this now. So what does this mean? So for this right here is a shorthand for using this. So as you can see right here, you can get a type-safe resource dot attributes, and you get the owner ID, or you can do the same thing right here. You can get the subject dot ID. So notice the $sign right here means that this value is going to be evaluated at runtime. So this is not a string. This is a value that's going to be evaluated at runtime. So notice this. And also the same thing for this. So we gave a grant for create read. So for example, right here, we added the same thing for the adapter, and we added the engine right here. So this is the Bob's post, and this is Alice's post. And we added an attribute right here, owner ID, which one has its own ID. So right now, Bob can read Bob's post, yes. And Bob can update Bob's post, yes. Bob can update or delete Alice's posts. No, he cannot, because Bob doesn't own these posts. It's pretty much simple. If you run this chapter here, and it works. True, full, false. These are the values that we actually expected. This is chapter 4. Check returns the full decision object. So what it means when we define a rule like this, when we grant read to the post and we build, that's okay. We do the pull like we've done before. Right now we have a post, which is the data we have retrieved from the backend or something like that. Right now we can check aloud. Engine.check Alice can read post. Can Alice read this post? And we're gonna get more information right here. So as you can see right here, the same as can, but returns the full decision. So when we log this, aloud is a boolean, as you can see right here. If you actually check the documentation for check, this is the whole object that you are seeing right here. So engine.can is a boolean. You only need yes or no. Engine.check is a decision object, which is all you need from decision with reason, timing, etc. These are all the things. To know more about this, you can pretty much just hover on this. You know, you're trying to access these values right here. As you can see, this is the whole API we have for the check. When you try to run this, as you can see, that's the whole object containing all the information that you need to know about this, even the conditions and everything you would ever need. So don't worry about it. It's pretty much, you know, handled free right here. So if you need to debug this, that's actually how you debug. There's a lot of things that you can use for debugging. See you in chapter 5. This is chapter 5, which is one of the new things we haven't discussed yet. So as you can see right here, we define a rule, which is editor. We grant everything, as you can see right here for him. Use the shorthand for this. Grant, CRUD, as you can see right here. You create a policy import policy from, you know, the library itself, and you give it an ID and you give it a name right here. The name is optional. You can actually add it or not. It takes, by the way, the name takes ID, takes the default value of the name is the ID. So if you didn't actually pass a name, it would actually, you know, take the ID as a name. So don't worry about it. And here is the algorithm. There is 4 different algorithms. We're going to talk about them next. These algorithms are here, as you can see right here, 4 things. And now we define rules. So each policy have rules. You can have multiple rules. So these rules are like this. You give it an ID, and you have a callback function that returns a rule builder, as you can see right here. So what do? You can actually deny or .allow, or you can do whatever you want. You can deny on, these are the actions. So you deny actions, create, update, and delete of all the resources, or you can actually, you know, say on a certain resource or something. And what do? This is the check. You can pretty much avoid the checking, but it's just going to apply on everything all the time. There is no checking right here, but we want to check right here. So you can check for when the environment variable day of the week in 0 to 6 right here. If you try to put it as 1, right now it doesn't actually have type safety because we're not enabling type safety yet. But when we enable type safety, it would work well. And important thing, must explicitly allow on non-weekend days, otherwise the policy denies by default when no rules match. This is the default value of the engine, because the engine right here does have a default value, which is effect. And when you check the default effect, it's default value to allow, to deny, I mean. So it denies when there is no match. So you have to change this if you want, but we just keep it deny because this is much safer. So we have to allow things otherwise. This is actually like a pretty explicit policy right here, explaining everything explicitly. So there is no implicit things that you need to figure out on your own or stuff like that. You do the same thing for a memory adapter, but right now we add policies the same way we add rules. And we have our own policy right here. We do the same checks, but we only add environments. So now the check right here introduces parameter right here. So this parameter right here, a new argument, I believe, yeah, a new argument right here. So the same can return the full decision. So it does actually take resource, and right after this there's environment, as you can see right here. This environment is the attributes that you want, like the environment attributes that this resource that you want to check on, or this resource actually does come with, or stuff like that. So for example, day of the week, like the IP, stuff like that, all things. There is default values here that you can see, like IPs, timestamps, user agent, or all these things. These are default things that you can check on and stuff like that. So when it's Bob delete and delete on day 1, it's true, he can delete on day 1 because it's Monday, but on Saturday he cannot delete because it's not allowed. Reading on weekends is allowed because we actually explicitly stated this right here. Also, you can pretty much chain rules here, so you can do .allow .on, something like that. You can actually remove this, but we made it explicit so each rule can have an ID for it, so it'll be explicitly easy while debugging or stuff like that. This is how it works. See you in chapter 6. So this is chapter 6, combining algorithm. These algorithms are very easy to understand. So let me define a concept. So when multiple rules match, the algorithm decides who wins. So the first one, deny overrides. One deny blocks everything. So we define a policy, we use an algorithm deny overrides, and deny deletes, deny action delete of all. So when you see right here, delete denies, deny wins over allow, as you can see right here. Read, allowed, no deny rule matches. Because when you actually read, there is no rule denying it. But when you have delete, this rule deny deleting. So it wins. So deleting is denied, but reading or updating or creating is not actually denied. So allow override, the second one, allow override, it's the opposite of this one. One rule is allowing, so the other rules are being overridden by it. So we actually have the same, this is actually permissive as an ID, algorithm allow override. We actually have a rule right here as an ID, the same, we deny everything of everything. And we actually have a rule right here, allow VIP. We build a rule, allow on everything of everything when an attribute, this actually, like right now we have attributes. By the way, this is later on going to be very type safe, but this is also right safe where you can actually have a lot of checks that you can do right here. This is the value. A VIP user allow wins over deny because it's actually like allow overrides, and normal users denied because they are not VIP. So the firewall policy, the first match order matters like firewall rules. So for example, block IP bad. So we created a rule right here, block bad IPs, and deny everything of everything when the IP is in this array 10.0.0.99, and we also allow internal when allow all when the IP start with this, and we also have rule deny external. We deny everything of everything when the like in general, like we only allow internal IPs. So as you can see right here, the IP is this, like 10.0.0.99 denied by the first rule. Not the second one, not the third one, only the first rule. So when when one rule denies, it skips. When one rule allows, it skips all the other ones. So 10.0.0.1 allowed by the second rule, not the first one or the third one. The third one, 8.8.8, is denied by the third one, not the first or the second one. As you can see right here, highest priority, emergency override pattern. So for example, imagine that you have a system and you want the emergency to have certain, like if you forgot the password, for example, and you want to override, you want to have some kind of like a recovery mode in your system, you need to have this. Is emergency responder? This is actually one of the attributes that we check for. If it's true, we set the priority to 999, which is actually going to override the priority of the 10 right here because it's a higher priority than the other one. So emergency responder priority is 999 wins, allowed, and everyone else is priority 10, so it doesn't actually allow. These combining algorithms are pretty cool if you know what you're doing with them. And this is actually chapter 6, and I'll tune at chapter 7. Chapter 7, scoped rules, multi-tenancy. So concept, a user can have different rules in different organizations. Like Alice is a viewer globally, Alice admin in org SME only. So how does this work? So you can pretty much define rules, and we created another rule for admin. We have set everything right here. We added we declared the engine right now, the most important part, which is the engine.admin. The .admin right here is a lazily created admin interface for CRUD operations on policies, rules, and subjects. By the way, the engine have This admin right here allows you to modify things inside the engine. Also, you can actually do the same thing with the adapter. It does actually, you know, expose certain setters and getters right here, as you can see. Also, the same thing for the engine. It does actually expose certain setters and getters and some checks right here, so you can do the same. So we assign a rule for Alice, admin, and org SME. We assign a rule for Alice, admin. The org is SME, org SME, which is, so she's only admin at this organization. Any other organization, without an organization, she's not an admin, she's just a viewer. So we do the same checks. Alice can delete a user. No, because she's not an admin. She cannot delete anything. She only can read, as we actually have explicitly stated right here. But if she's an organization named with an ID org SME, now she can, because she is an admin in this organization. We actually have set this right here. But if she is in a different organization, she cannot do anything because she's a viewer. She's only admin in an organization with an ID org SME. So that's it. That's actually the scope. Also, you can make certain rules related to certain organizations. So you can do org SME right here. So this is a viewer only related to scope SME if you want to do it. Also, you can grant scope, as you can see right here. As you can see right here, you can grant scope. You can grant a singular permission restricted to specific scope. And yeah, you can actually learn more about this in the documentations. These are like more shorthands you can use. See you in chapter 8. Chapter 8, explain for debugging. We actually have talked about check, and we actually have talked about can. These things are pretty cool when it comes to checking and debugging, but right now we actually have to get like so we actually have created a policy, not a policy, a rule right here. We gave it grant. We granted when a user is an owner, and we actually have stated everything here. And we have a post within type post, and we actually have an owner ID with Alice. This is Alice post. So explain. Can Bob update Alice's post? No, he cannot. So this is actually like the trace. As you can see right here, it does actually include a lot of things. So it does include a lot of things that you can get. All these things are read-only, so don't worry about that. It's type safe. So you can get a summary. A summary gets you this. Denied Bob update on post rule. So this actually gives you, this is actually the object, as you can see right here, including everything that you need to know, including the summary. This is the summary, telling you what's really going on and why it's denied and stuff like that. This is the full trace, including everything you need to know. This is actually for debugging. If you want to debug with us, you can pretty much dig into the trace. As you can see, decision allowed, even the children's of the conditions. Everything that you need to know is right there. All right. See you at chapter 9. All right. This is chapter 9, which is permissions for patch checks. No wonder if you wanted to check a lot of things in your UI, you're not going to check one by one. You want to check a lot of things and want to get the output of all this. We define rules right here. We give them permissions, put them in the engine. Right now, we get the most interesting part, which is permissions right here. When you hover on it, it tells patch check. So it checks things. Evaluate many permissions at once for a single subject. Returns a permission map keyed by action resource. So, for example, if you said read post, so it will be read post concatenated with a colon, or a scope action resource, as you can see right here. Lead DB data once, evaluate many. And each check goes through scoped rule environment and hooks consistent with authorize. So we get read post true and create post true and all these values, as you can see right here. So you get all the checks, all the values of all the checks right here as a map. Like if you can use these values right now in the client, so you can see like perms, delete, post. See you at chapter 10. Chapter 10. This is actually a brief of chapter 10. This is not fully chapter 10, but I wanted to show you how to do type safety manually without using our own, primitives. You can pretty much do type safety to this library without actually using our own stuff. So we have actually defined types for actions. These are the actions we're gonna do. These are the resources. These are the rule IDs, and these are the scopes, guest, viewer, author, or stuff like that. These are the organizations we have. You can define these things as types. So right here, we create a function, takes a rule ID, return a defined rule. We pass all of these generics right here. So right now, when we try to create a rule right here, now we get IntelliSense, as you can see right here. We get IntelliSense here. We get IntelliSense also here. Also, we get IntelliSense here, as you can see. We also get IntelliSense everywhere. We get IntelliSense. Even on the checks here, you get IntelliSense, as you can see right here. And also here, you get IntelliSense. So you get IntelliSense everywhere when you do such a thing like that. It's just the same. Also, for the memory adapter, you can pass the parameters the same way right here to make sure it works. Also, the engine right here takes its type from the adapter, so don't worry about it. It does know what it takes. But it works, right? Also, the memory adapt, you don't need to pass it to the memory adapter. The memory adapter knows the types from the rules themselves here. So it does inherits everything from here. So you don't need to pass the parameters to this one right here. Also, you can do the same checks as they are. So let me show you the full version of type safety right now. So this is actually chapter 10, which is create access config, production setup. This is actually like how you do it in production. This way is more clean and more like structured. So as you can see right here, we create access config. This create access config takes action, resources, scopes, and rules. As you can see right here, it does actually result. So create a type safe access configuration for your application. So this access right here does have everything. Access does have when rules. It does have everything we have in the library, but it's type safe now. So you don't need to configure it yourself. So you get the same type safety that I told you about. So you get the same type safety here. You know what I mean? The same type safety here. You know what I mean? You get the same type safety everywhere, as you can see right here. But you don't get type safety here. So how you can get type safety here? Also, if I wanted to put this as an array, it doesn't actually tell me anything. So to get type safety here, you need to extend something so-called context. So what is a context? So if you actually hover on this access config here, or you hover on anything, you would see something right here called, let me just remove this context here. When you hover on this, you see something, I see a generic parameter right here called default context. This is the default context. So when you go to this right here, and you check the default context in the library itself, this is actually the default context that we have. Like the subject does have certain attributes, and does have an environment, scopes, and everything. So this is actually what we have here as a default context. So when we get back here, the access config right here accepts a context, which is a phantom field for context type interface. So pass an object as unknown as your context to enable type .path intelligence on .attributes or .resource attributes and checks the runtime values. So you want to get fully type safety right here, just add the context here. So you make your own context, you extend it with the values you want to add. And right now, as you can see, this right here, where is it? When I do this as an array now, look, it does panic to me. Also, I get intelligence to this right here. Look, I get intelligence. I get intelligence right here for the values I have. Also, it tells me, oh, if this is only a number, so this shouldn't be an array. Also, right here on the app, I get I get intelligence, as you can see right here. Also, for the day of the week, if I made this a number, it would actually panic at me. Let me just remove this. It would panic at me, as you can see right here. If I made this true, it would also panic. It only accepts an array of numbers, so it wouldn't actually panic until I validate this right. This is how you do type safety in general. Right now, you get full type safe stuffs. Right now, I believe terms are type safe, so you can pretty much do this. As you can see right here, you get all the types that you want. So right now, your front end wouldn't actually panic while actually trying to get the keys right. Right now, it's fully type safe. That's actually the world that I live in, and I wanted you guys to live in with me. This is actually the end of chapter 10, maybe the end of this video. See you. So here's what we built. We started a single rule, a single permission check. Then we added an inheritance. Viewers became editors, became admins, and also we attached conditions to permissions, so authors can only edit their own posts. We layered ABAC policies on top. For time-based and environment-based rules. We handled multi-tenancy with scope rules. We debugged a denial with explain. We patched permissions for clients, and we built and we tied everything together with fully typed production setup. This is a complete authorization system from zero. What makes this different from an if statement buried in a root handler is that your authorization rules are now centralized, auditable, debuggable, testable, and type safe. If you are moving to production, the next thing to look at are swap in memory adapter for Prisma or Drizzle to persist rules and policies in your database. Connect the client libraries so your React or Vue app can hide and show UI elements without extra round trips. Setting up the server middleware for ExpressHono, Next.js, or Nest.js so every route is protected automatically. All of that is in the docs. duck-iam is open source. If this saved you 3 weeks of writing authorization middleware from scratch, give it a star. If something is broken or missing, open an issue. Thanks for watching. Go ship something.